Hello everyone, I hope you are doing well. In this video, we'll be solving problem 4 from chapter 4 of Introduction to Statistical Mechanics by Roger Bowley. Let's see the problem statement and we'll dive directly into the solution. So the statement says, here's the statement. It's a line statement. It's a very short statement, very good statement. How much heat must be added to a system at 298 Kelvin for the number of accessible states to increase by a factor of 10 to the power 6? So what we are given with here is the temperature, which is 298 Kelvin, and the factor by which the number of accessible states are increased. So it's 10 to the power 6. And what we have to find out is the amount of heat that has to be added to make this effect. Okay, so if you are wondering that what concepts relates to this problem, then the concept that discusses the number of accessible states, heat and temperature is entropy, and we'll see that how entropy and its definition in its formula will help us to find out the heat that must be added for all of these stuff to happen. Okay, so let's do that. The problem is really simple, and let's write the data. We have temperature, let it be represented by capital T, 298 Kelvin. Then we have number of accessible states that increases by factor, which is WF by WI. This is the notation that has been used in the book as well. That is why I'm using it here. It's 10 to the power 6. And we have to find out the Q that must be added to do so. For solution, we know that according to Boltzmann definition of entropy, which actually relates entropy with the number of accessible states available in a system. So entropy change or increase is given by Kb natural log of Wf by Wi. Alright, this is the entropy that has been increased, okay, because of increase in number of accessible states. So this is one of the formula, and we know that from general thermodynamics, that entropy for a system at fixed temperature T is given by entropy increase equals Q added divided by the temperature at which the Q has been added. Okay, so we can equate both of these equations now. We can equate it because we can see that the right, that's left hand side, the left hand side has S in it and they are both equal, and we can put them equal to each other. So Q by T is equals to, since they are equal, so they will be equal as well, Kb natural log of Wf by Wi. Since we need the Q added, so Q added will be equals to, T will be taken here, Kb is Boltzmann constant simply, and that's the formula that we need to calculate the heat added. Let's call it as 3. Let's put the values into this formula to get the heat that is needed. Kb is 1.38 multiplied 10 to the power minus 23. T is 298 Kelvin. They're all needs to be inserted in SI units. Natural log of 10 to the power 6. Alright, so this is Q added. Let's do this on calculator and see what result we are gonna get. And the result will be in joule because all of the units were in SI units. So the SI unit of heat is joule. So let's see. Here is what we got. It's 5.68 multiplied 10 to the power minus 20 joule. 5.68 multiplied 10 to the power minus 20 joule, and we want to convert it into electron volts, and for that purpose what we do is to divide it by the charge on electron, which is 1.602 multiplied 10 to the power minus 19. Doing so converts this into electron volt. Okay, so let's see what result we will get on doing so. Always use brackets when we have multiple numbers. is 0.355 electron volt. Okay, that is the result, and this is the amount of heat that has to be added to a system at temperature 298 Kelvin for its accessible states to increase by a factor of 10 to the power 6. Okay, so that is it for this video, and if you want solutions to other problems, or if you want conceptual based videos, or if you want derivations based videos on statistical mechanics from this book, which is Introduction to Statistical Mechanics by Roger Bole, or from different books like including Reef, and there are multiple books that I have covered from the same subject or from different subjects, including solid state physics, quantum mechanics, nuclear physics, digital electronics, and whatnot. So if you are wondering where are these videos, so you can simply comment down. I'll direct you to your desired video as quickly as possible within an hour, because I'm very quick at responding to comments. So yeah, that's it. Like, share, and subscribe. Goodbye. Take care.